Hi ladies and gentlemen, this is Thijs from Varnish Software. In this video I'll explain how to offload a JFrog Artifactory setup with Varnish Virtual Registry to reduce both network latency and egress charges. JFrog Artifactory is what they call a universal repository manager. It's a system that exposes a set of registries that organizations use to store and deliver their artifacts, which means the dependencies that are part of their software supply chain. That could be Debian packages, RPM packages, Docker images, Helm charts, NPM packages, Python packages, Rust crates, Go modules, the list goes on and on and on. Whatever file it is, if it's needed as part of the software supply chain, Artifactory will host it. And that applies to public artifacts as well as private artifacts that are protected through centralized access control mechanisms and a whole range of governance and management tools. And despite the incredible value that Artifactory brings, it has some unique challenges, most of which are related to performance and scalability, especially on self-hosted Artifactory setups. I talked about that in a previous video and I explained how the Varnish Virtual Registry can accelerate that. But today we'll primarily focus on the SaaS version of Artifactory, the one that is hosted in the cloud. There it's not necessarily about raw performance and the scalability of the platform, but the challenges are network latency because of the network and the distance between the consumer and the Artifactory setup in the cloud, and of course the bandwidth, the egress charges that are an important factor as well. A virtual registry, as the name implies, is not a real registry. It doesn't serve as the source of truth, it doesn't host the packages itself. Instead, it's a virtual layer, a proxy if you will, that you position in front of Artifactory to offload all the pressure, to make access to your artifacts faster, and to reduce your network bill. And this happens through intelligent caching and routing. And the key is to position your virtual registry exactly where you need them, as close to the consumers as possible. Those could be your CI workers, your CD deployment targets, or even individual developers. Allow me to show you how easy it is to get started. The Varnish Virtual Registry, which we call Project Orca, is available on www.varnish-software.com/orca. And as you can see, it's as simple as doing a Docker pull. But if you move down, you have the different install types. You can deploy it locally via Docker, you can orchestrate it on a Kubernetes cluster, or we have packages for Debian and RPM-based systems. Orca is configured through a single YAML config file and has different types of config entries, some of which are related to the Varnish engine underneath, others to licensing, and others that aren't shown here. But in this video, we'll focus on the virtual registry entries, and we already have two pre-configured entries, one for the Docker Hub and one for NPM packages. So let's add our own, call it Artifactory, and link it through a remote, of which the URL comes with our SaaS subscription of JFrog. In our case, that's vsdemo.jfrog.io. Before we use that config file as part of a local Orca deployment, I want to show you how much time it actually takes to perform a Docker pull and pull a Docker image from that cloud-based JFrog Artifactory setup. So doing a Docker pull from vsdemo.jfrog.io, the name of our registry on Artifactory is called Docker, and the name of the image is to do. We add the time command in front of the Docker pull to see how much time it takes. We run the command and you can see that the different layers of the Docker image are now pulled in. And when I fast forward, for your convenience of course, we see that the total time it took to download the Docker image is 56 seconds. Our goal is to access that same Docker image, but through a locally deployed Varnish Virtual Registry, avoiding unnecessary repetitive downloads from the cloud, making access faster, and reducing bandwidth consumption. And we'll do that via Docker. This is the Docker run command that we use to deploy Orca locally on my system. As soon as that happens, you see the banner and all the logging information, and you see the Artifactory entry that was registered. We can now open up a secondary terminal and pull the Docker image through Orca. I can now run another Docker pull for the to-do image, but rather than sending requests directly to Artifactory, I'm routing them through artifactory.localhost, so that directly hits my local Orca deployment. Because the subdomain matches the name of the key in the virtual registry entry, it knows exactly where the route requests to. And because I add the time command in front of it, we'll measure how long it takes. But, word of warning, I do not have high expectations because the cache is empty. It won't necessarily be faster the first time around. So let's see the result. As the layers are downloading, I'm going to fast forward it for your convenience and see how long it took. And the end result is that it took 56 seconds to pull the image in, including downloads and extraction of the files. That's not that fast. We can do a lot better. But since we now have filled up the cache, when we remove the image again and try again, the results will be a lot more impressive. Let me fast forward again and take you straight to the outcome, and the numbers are quite impressive. The total time it took to perform the Docker pull on a full cache is 11.6 seconds, of which the majority of the time is spent extracting the packages. The downloads themselves took mere milliseconds. Compare that to the 56 seconds it took on an empty cache, that's almost a 5x performance improvement. Now that's for a single Docker pull. Let's see what happens under sustained pressure. To measure the effects of sustained traffic on a Varnish Virtual Registry instance, you need some kind of observability layer. And luckily, Orca supports OpenTelemetry, which you can configure in your Orca config file. So it's just a matter of defining an OTel key and giving it a service name, which we call Orca now. Then it's a matter of providing metrics endpoints, endpoints for logging, and of course endpoints for tracing, all of which point to an endpoint of an OpenTelemetry collector. The host.internal.docker domain is what you use to reach the host system, and we're using port 4318. This points at a separate telemetry stack that I've deployed using Docker. This is what that looks like. It has nothing to do with Orca, but I'm running it on the side and it has a bunch of interesting components. We're bootstrapping a low-key instance for log centralization, Prometheus for metrics, and Tempo for traces. All of it is aggregated through an OTel collector listening on port 4318. That's the one we're using. And finally, we're using Grafana as a dashboard service exposed on port 3000 to visualize all that data. I can launch the Orca container again on my local system with the updated config that points to the observability stack, but of course, I need to launch the observability stack itself. I do this by running docker compose up in the right folder. I can now open a browser window, navigate to localhost on port 3000, which forwards traffic to my Grafana container inside my observability stack. Grafana is a dashboard service that we use to visualize telemetry data. You can create dashboards from the different data streams, but you can also explore the raw data, such as the metrics and the logs. To benefit from Grafana, I need to send a lot more traffic and produce a lot more telemetry data. And earlier I mentioned measuring the effects of sending sustained traffic to Varnish Virtual Registry. Well, this is the perfect occasion. I'm going to use an automated load testing tool called K6 to do that. It's an open source piece of technology that is developed by the people at Grafana Labs. K6 allows you to define scenarios in JavaScript, and I actually wrote a script that mimics Docker pulls for that to-do image. The script is configurable to a set of environment variables and allows you to configure the URL of the registry, the name of the registry, and it also sets the fact that the to-do image is going to be downloaded, specifically the latest tag. And the rest of the script is nothing more than just setting up everything you need to perform the HTTP requests for the basic endpoint, for the manifest, for the binary layers. It handles authentication, it follows redirects, and so on and so forth. This is not a stress test. We're only issuing a single virtual user, so there's no concurrent traffic, but we are doing sequential iterations, 200 of them, to have some sort of sustained traffic pattern. The way we're going to run this test is by calling the K6 run command inside this bash script. It points at the docker_pull.js scenario, and output is being sent via OpenTelemetry. All of this needs to be configured, both the OpenTelemetry side of K6 as well as the registry settings. This is done in the .env file, where we configure the registry URL and the name. For the initial test, we'll point it directly at the JFrog setup in the cloud and reference the name of the registry, which is called Docker, the username and the password, which is enforced by Orca, but actually managed by Artifactory itself. And all the rest is just K6 OpenTelemetry configuration to ensure that the test results end up in the same observability stack. I can now run that bash script to execute the test. You can see that the K6 program is bootstrapped and all the requests are being made directly to the JFrog Artifactory setup. And again, this script mimics the behavior of doing the Docker pull for the to-do image. The output and the measurements of the running test can be viewed in the corresponding dashboard in Grafana. You can see that there is a single active virtual user and that the Docker manifests are loaded quite fast, 73 milliseconds at the 95th percentile. Then again, this is textual data, small files. It's supposed to be fast. What is slower though are the binary layers that we're downloading. At the 95th percentile, it takes 6 seconds per request, so that's kind of slow. And while the throughput is climbing, 180 megabits is not exactly inspiring. So let's run that same test again, but directly through Orca. And to do that, we need to switch the registry endpoint. So we'll point it at artifactory.localhost, restart the K6 tests, validate that the requests are being sent to artifactory.localhost, and see what the outcome is. Moving back to our Grafana dashboard, the performance improvements are visible. We see a sudden spike in throughput, which is caused by a lot lower latency. That's actually the virtual registry doing its thing. And this is also reflected in the request durations, especially for the binary layers. At the 95th percentile, we've dropped from 6 seconds to 220 milliseconds. That's very impressive. And even at the 50th percentile, values are super low. Throughput is now spiking to a gigabyte and now to 1.47 gigabits per second. And let me show you something extra, because we have a hidden panel here that visualizes virtual registry performance, because we are actually sending traffic through a virtual registry. The traffic increase is visible, and at the same time, backend traffic to Artifactory is ridiculously low. And at 10.4 kilobits per second, traffic to the registry is almost negligible. In terms of offload, almost 100% of the bytes are offloaded and 72.8% of all requests. Throughput keeps increasing and we're almost at 2 gigabits per second, all because of lowered latency, and that's especially visible for the request duration to download layers. We've dropped from 6 seconds to 165 milliseconds. That is a 36x improvement. And that, ladies and gentlemen, is how you offload a JFrog Artifactory setup. Thank you for watching this video. If you want to get started straight away with the Varnish Virtual Registry, go to varnish-software.com/orca. You'll find install instructions for Docker, for Kubernetes, and for Linux packages. You'll also find a form to request a free trial for the premium features, and there's even a widget available to get in touch with us directly.